This is the 310 to 311 review. Calculators are not allowed. And we have one problem for this. It says the radius of a sphere is increasing at a constant rate. In terms of the surface area, what is the rate of change of the volume of the sphere in cubic centimeters per second? So this problem is a little different than most of the other related rates problems because I do not give you an instant in time. Instead, I am just asking for a relationship between the rates. But we can still go through some of the steps in an effort to try and answer the question. So, first of all, it looks like we're working with a sphere. And we know the radius of that sphere we can label as r. I know my dr dt, and it says in terms of the surface area, what is the rate of change of the volume? So that means I want dv dt. So that tells me for step 2 that I need to set up an equation that relates the radius and the volume of a sphere. So that formula is 4/3 pi r cubed. So step 3 now is I need to take the derivative of both of these with respect to time. If I take the derivative of v, I get dv dt. If I take the derivative of 4/3 pi r cubed, I will get a 4 pi r squared dr dt. Because I multiplied by the 3, decreased the power by 1, everything else was a constant. So now, we want to write dv dt in terms of the surface area. So if we remember that our surface area is 4 pi r squared, and we realize that dr dt is a constant of 0.2, then we've now written dv dt in terms of the surface area. So in this case, we would have dv dt equals 0.2 times surface area, and the units will be, since it's a volume, centimeters cubed per second.